Hi, a few of you had trouble going through questions 4 and 5 from chapters 19.5, so I've just created a short video to go through how to do it. So for question 4, my workings are here, but I'll just talk through using the pointer so you can see where I'm going with things. So an absorption line is observed in the spectrum of a particular gas when electrons absorb photons and move between energy levels at minus 10.4 eV and minus 4.6 eV. So all I did, just for my own use really, was to draw a diagram of the minus 10.4, the minus 4.6, labelled it with EV, and just reminded myself that we've got an electron moving up, or a photon of light coming down as it, or coming out as it goes down. A couple of reasons to draw a quick diagram is it just visualises what I need to do to answer the question, and it reminds me that I need to find the difference between energy levels. So 10.4 minus 4.6 gives 5.8 EV. But in order for all the equations to work, we need the answer in joules. So we need to convert 5.8 EV into joules, and we do that by multiplying by 1.6 times 10 to the minus 19, and that's the value of the charge of one electron. So you plug it into a calculator and you get 9.28 times 10 to the minus 19. And the key thing is we've now got it in joules. In my head, I always just would write down E equals HF, but I then have reread the question and I notice they want wavelength. So I then think, okay, HC over lambda. So I rearrange for lambda, HC divided by energy, where H is Planck's constant, 6.63 times 10 to the minus 34. C is the speed of light, 3 times 10 to the 8. And then my answer for energy, I've carried forward from there. I've then put that into a calculator, 2.1 times 10 to the minus 7, and then more commonly, when you talk about wavelengths, it's times 10 to the minus 9 for nanometers, so I've just changed that to 210 nanometers. It would have been absolutely fine to have left my answer as 2.1 times 10 to the minus 7 meters, unless they'd asked specifically for the answer to be in nanometers. For question 5. Looks slightly more complicated, but again, all I've done is I've just written down all my workings whilst doing it. So for question 5, the value of the energy level in EV for the hydrogen atom is given by the equation En equals minus 13.6 over n squared. Now at first I thought, ooh, what's that? But then I recognised what was going on. So n are the energy levels, and then I've just drawn them just here again to help me visualise what we need to do. So it says, draw an energy level diagram to scale for the hydrogen atom showing the 5 lowest energy levels. Now, as you can see, I've just done 3. You can do 4 and 5 in your own time. And then I haven't drawn it to scale. All you'd need to do is just plot it like you would a normal graph. So because I've realised that n is an energy level, I've subbed in some values. I'll just put 1, so 13.6 divided by 1 squared. And then 2, 13.6 divided by 2 squared, so 13.6 divided by 4. And then for n equals 3, 13.6 divided by 3 squared, 9. And then from that, I've then got the values. For part B, it asks you to determine the wavelength of the emitted photon when an electron makes the transition between levels n equals 3 and n equals 2. Well, again, because I've drawn it, I can visualise what I need to do. I need to find the difference between those two energy values, the 3.4 and the 1.5. So N3 minus N2, as I've called it, which should really be E3 minus E2 because it's energy. And that then works out to be 1.9 EV. When you look in the answers in your book, they've actually used 1.89, so the final answer is slightly different. So again, I've then converted 1.9 EV into joules, and I've multiplied, like before, by the charge on an electron, 1.6 times 10 to the minus 19. I've then double checked the question, and yet they want the wavelength, so I've rearranged HC over lambda for lambda equals HC over E. And I've plugged in the numbers, Planck's constant, speed of light, and then the value that I've calculated just there. And it comes through at 6.54 times 10 to the minus 7 meters. And again, if you wanted to convert it, not that it asked you to, it's 654 nanometers. But again, when you look in your book, the difference in number is because I use 1.9 here rather than 1.89. I hope that helps. Go through questions 4 and 5. If you have any queries, please get back to me.